It's working now. So once you have a one-to-one function, right? Graphically, it looks something like this or something like this. What am I trying to say? One-to-one functions are functions that never take on the same value twice. Do we get that? So once you have a curve in the graph, we can see that once we draw a vertical line, right, we can have different values giving us the same value. I don't know if you get me, but over here, right, we can have, let's say we have 4 on a vertical axis. Now when we map 4 on the graph, we can see that x, this is the x-axis, right? This is the x-axis, this is the y. So 2 and 4 gives us the same value, right? So when we put in f of 2 and also we put in f of 4, we get the same value on the y-axis, which is what 4. And this is not a one-to-one functions. So one-to-one functions, as the definition gives, are functions that never take on the same value twice. And what this also means is that it is either increasing or either decreasing. Once it's increasing and it's also decreasing, then it's not a one-to-one function. Right, so we've seen the graphical representation of what we meant by this, that it shouldn't be a curve, because once you are having a curve, then it means that it was decreasing, then it came down and is now increasing or something. Do we get it? So that's what we said for one-to-one function. And as we did before, right? The example we just did, we drew a horizontal line and saw that, okay, since the value of x as 2 and the value of x as 4 gives us the same value for on the y-axis, then it's not a one-to-one function. What this law is called is the horizontal line test. So how do we do this? We just draw a horizontal line in our graph. Now, once the graph cuts more than one point of the function, then we can conclude that the function that we have is not a one-to-one function. Do we get it? This is just the application part so that we use this same concept in solving our solution. Please do we get it? So please pay attention. Now let's come to the how to calculate um, inverse functions. So now what's the link between one-to-one functions and inverse functions? They have let me say mother-child relationship, right? Every inverse function must first be a one-to-one function. Okay, so every inverse function that you know is a one-to-one function. So once you are given a graph or a sketch and you are asked to tell if the function in that graph is an inverse function, you can first of all use the horizontal line test, which we saw earlier, right? We test for how inverse, let me put it that way, how we test whether the function is a one-to-one function, right? So if we have an example that we are showing in this scenario, then we can conclude that the function is not has no inverse because it's not one-to-one. Please, do we get it? So that's the relation between a one-to-one function and an inverse function. We are saying that every inverse function should first be a one-to-one function. Let's go back to our slide and see a relation that we've been given. So if we have the function, okay, so if you have the function f inverse of y is equal to x, we can write the relation f of x is equal to y. Now this is a very powerful relation. It looks simple, but it's actually very powerful, and we would be using it in the calculation that we are going to do, right? So can we explain this graphically? Yes, we can. So what does this function, this relation that we've drawn here represent? And what this means is that provided we have a graph that goes this way, we have a graph that goes this way, and let's see. So once you have your function going this way, okay, you are mapping. So let's label our graph. We have 1, 3, and 4. Then we have 1, 2, and we have 3. Okay. Once we have a graph this way, okay, we have a graph that looks like this, and we've been told that the graph, right, the function has an inverse. We can predict where the inverse function would be from these two equations that we have. Do we get it? So if you have the function giving you the 2 points, if you can map out a point on the function, on the original function, let's say 2 1. Okay, if you can map out 2 1, sorry, 1 2, right, the x first followed by the y. So if you can map out, let me clear this, please pay attention to this point. If you can map out 1 2 on the original function, then let your inverse function, okay, so let me just use the same inverse. So your inverse function would be what? 2 1. Now this is what we are seeing over here. This is the relation that we are seeing. I want you to get the relation that we are using over here. So for me to get my inverse point from this, for me to get my original function from this inverse plotting that we've gotten, all I need to do is that, okay, I have to swap the x and the y, and what do I get? I get f of 1 2, just as we have at the top. So do we get a relation between a function and its inverse? And one thing that we also should know is that a function and its inverse show mirror property about the line y is equal to x. So what is this line? When you plot 1 1, 2 2, 3 3, 4 4, and it goes in that order from the origin, right? You see that when you draw a function and you draw its inverse, you have mirror images about the line. So the inverse will give you something like this, right? This is your mirror, and your function and its inverse should um be directly mirror images to each other. Please hope we get a link. This is the graphical representation of a function and its inverse. So what are we saying? If we have a function that the inverse point is what? 2 1, we can easily swap the x and the y to get the original function, which is what? 1 2. This is the first one. And from this we deduce the relation that, okay, f inverse of y is equal to x. So f of x gives us what? Gives us y. We've also seen this graphically by saying that every function and its inverse are mirror images of each other. Hope you get a link. Now there's one question that comes in a lot of um, so let me just explain what this. So let's quickly do this. Do this. Um, Let me quickly cut this. Why is this thing delaying me? Just a minute. I want us to use the board. Isn't this working? Okay, so let me just try one last time. Okay, so